So welcome all for the image lecture series on this image medical image processing. So now in the module 5 we'll see about the image compression. So the topics to be covered here are nothing but the image introduction to image compression, lossless and lossy compression, Huffman coding techniques and arithmetic coding techniques. So what is meant by image compression? So image compression is very important thing so that we are doing in all the digital devices. So if you want to send an image from one device to another device, so you need the first thing is nothing but you need to first an important thing is nothing but you need to compress the image. Okay, so without losing any of the detailed information. Okay, so this is in this figure to given an image of size 270 KB. It is compressed to an image of size 22 KB. So without losing any of its fundamental details. Okay. So the image compression is the process of reducing the amount of data required to represent an image. Okay. So you are having an image. You have to compress it and you have to store it, and it is transmitting through the channel, and with the receiver device it should be decompressed and we'll be getting an estimated image. So here we are sending an input image f of x comma y, but the output image what you are getting is nothing but f of x comma y. So it is always not same as that of your input image. So definitely when the compression is doing, so there are some of the fine details will be missing. So that is nothing but only an estimated image. So here having an original image, so it should be encoded and it is passing through the channel in forms of bit streams, that is zeros and ones, and the receiver it is decoded and the image is displayed. So the image compression involves reducing the size of an image data while retaining the necessary information. That's very important. Retaining necessary information depends upon the application. The image segmentation method, which are primarily a data reduction process, can be used for compression. So the ratio of the original and the uncompressed image and the compressed image, okay, the ratio of the compressed and uncompressed image, it will give the compression ratio. So this is already we discussed image. It is passing through a source encoder and the transmitter and channel encoder. It is passing through a channel and store it, and it is giving in the channel decoder and the source decoder. So what are the fundamental steps we have to do before doing an image compression? That is nothing but first one is the data preparation or the image preparation. So that is nothing but you have to convert the analog to digital conversion. Okay, so all the devices that we are using for transferring or storing the images are nothing but digital devices. So definitely you have to convert the analog image to a digital image. Then you have to process the data. Okay, so you have to transform the data and you have to, that is suitable for the compression. Then you have to do the quantization to get the precision and to reduce the precision at the output to be stored, and entropy encoding. So these are the methods to be done when you are going for compression an image. Then we'll say about what is about lossless compression and lossy compression. So the original image can be recovered exactly with high quality and bigger. So that is called what? The lossless compression. Here the information is preserving. Okay. In lossy compression, only an approximation of the original can be recovered. Low quality and will be smaller. Okay. So lossy, an approximation or a part of the image only can be recovered after decompressing the image. So, and this having the low quality and the image is also looks smaller. So that is resolution of features should be, so image compression, which one to be chosen, lossless or lossy. So that is resolution of features should be unchanged or human perception. So relative data redundancy of the first data set is RD like 1 minus 1. So here one of the main important thing that we have to consider in the lossless or lossy is nothing but the data redundancy. Okay. So anyway we have to remove some of the pixels in the image. Okay, so based on what we have to remove it for compression, right? So that is based upon the redundancy of the pixels. Okay, so in some part of the image, Okay, some of the pixels will be repeated. So that pixels, if it is repeated, there won't be any use of any, like that values won't be of any use, or the pixels won't be of any use because it is giving the same information from the other pixels. So what we have to do, we don't need to we don't need to keep all the images. So we can remove the redundant images and we can do for the compression. So in digital image, the redundancies are of three types: coding redundancy, interpixel redundancy, and psychovisual redundancy. So the compression algorithm is developed by this type of redundancy. First one is a coding redundancy. This occurs when the data used to represent the image is not utilized in the optimal manner. Okay, and interpixel redundancy is nothing but the adjacent pixels tend to be highly correlated in most images. The bright levels do not change rapidly but change gradually. Okay, so that is the interpixels redundancy. And psychovisual redundancy, some information is more important to the human visual system and other types are not important. So that is a psychovisual redundancy. So that is nothing but when you're seeing an image, so some of the things in the image will be very catchy, or will be observing that. The other things are nothing but we won't observe it much. So that will be taken as a redundant pixels. So that's all about the introduction about the image compression. So we'll see about arithmetic coding in the next class.